Well, hi, good morning. Thank you so much for joining me in my shop here on the 8th of August. A gray, rainy day here, second one in a row. So I think I'm finished experimenting to a large part with the long cables I was running out of here. Things didn't go all that well for me yesterday, but I think I've drawn an important conclusion here. It sounds kind of silly or simple when you first hear it, and that is shorter cables, the better. The shorter, the better when you're doing this kind of work. So in other words, a cable that runs between the transmitter and the meter itself that you're trying to measure something with, shorter is better. Now, I would have thought when I started this that a cable like, let's say this one, this is short. I would call this short. I mean, in my world, a long cable is many meters long. Maybe the run going right up to the antenna. That's a long cable. This is a short cable. It's a jumper cable. You can call them jumper cable. Well, turns out even something this long appears to have a significant impact on the meter. And I have done more reading. Oh my God, how much reading have I done over my life on this particular topic? I'm not embarrassed to be confused about it because I think just about everybody is. We're talking about standing wave ratio and making measurements in transmission lines and matching impedances and this whole world. And you know, what's a 50 ohm cable anyway? What does it mean when it says 50 ohms? I can't get an ohm meter and read 50 ohms off this. So what's that mean exactly? I'm not answering these questions. I have answers. They are my own answers now. I'm not going to share them because I think at least half ham radio operators and others who are involved in this kind of issue are really quite off the mark with what they think, and I think I'm still in that half. So I'm not going to share too much here with what I really believe is going on in these cables. Nothing mysterious about it. It's just mysterious. That's the thing. So we're going to do a few more experiments here with just these short cables and this radio. I did manage to get this radio to show 4 watts on this meter, or just about 4 watts, and to me that's kind of a sign of getting it right, because I really believe 4 watts are coming out of this thing. And so we're going to start off with a short cable. I'll show you the shortest cable is this. We're going to get down to this. Now that's a short cable. We're going to try to use these. I got 2 of them. And that pretty much eliminates the cable. Well, there's wires inside the radio in that too. Now we're going to just see what we can find out fairly quickly by doing that. So I'll get things set up for that. A few experiments here. So another thing to think about, which I haven't mentioned but has been on my mind the whole time, is that these little power meters are not power meters at all. That's a voltmeter. And it will, and it's calibrated in watts, based on the idea that this is hooked up to a certain kind of circuit with certain kinds of things going on and other kinds of things not going on, such as standing waves or whatever it might be. So although it says watts, it says power, that's a voltmeter, and it was really just measuring voltage. And of course the voltage in these lines, if there's any standing wave activity at all, is going to be high in some areas and low in others, and this meter's baloney. So, but I do have it connected to the radio, and I have a 50 ohm load right here. Inside here is a 50 ohm resistor. We're going to see now, can I duplicate what I did before? There we go. Just put the squelch up so we're not hearing that. Let's hope this meter says 4. 4 is just up here where my finger is. 4, right on the money. It's right on 4. Excellent. Fantastic. Now we're just going to put a little bit of a longer cable in here. So it looks like, and this is the rule I'm coming up with, this is not something I read, is if you take a wavelength, 11 meters in this case, a wavelength like that, you take a quarter of it, which would be roughly 3 meters, That's quite a bit. A quarter of it, 3, maybe 2.5 meters. That's quite long. That's over 2.5 yards if you're American. And so this little cable is substantially below a quarter wave. I mean, this is really quite short. We're going to jump to the slightly longer one here. Okay, so this one is about, I would say it's not even a meter long. And another assumption here is all these cables are good, and I don't have a defective cable that I'm working with here. Of course, another assumption is this meter is accurate. If you do supply it with what it wants, it'll show up properly. That's another assumption. Here we go. How many watts? 6 watts. I got more power. More power. So there we are. Now, you really got to wonder, is that 4 real, or is that just, a happy coincidence? Well, we're going to shorten this cable down to the shortest it can possibly ever be. Like this connector here. So this has, I'm using CB radios to do this, but this clearly has implications for any other transmitter. And so if you're a ham radio operator, although I'm fooling around with CB, CB, well, it's just another transceiver, isn't it? With its own band. Okay, so this just doesn't get any shorter. I don't know how to make it any shorter than that. Now that is short. Okay, let's pray for 4. If it's not 4, then I'm quitting. Ready? It's 3. It's 3. So all this is about setting myself up to do a calibration on this machine over here. And I just wanted to be sure of things before I start trying to calibrate this. And am I sure yet? Oh my gosh. That was unexpected. Yeah, my thinking is all the power coming out of here. And that's my thinking. That's the end of my thinking right there. Well, let's do something really crazy. We'll put this on the end of a I have to get a connector. We'll put the load out on the end of a piece of wire. And what the heck for? Well, why not? Doing this kind of stuff just raises so many uncomfortable questions with everything that we do in electronics or ham radio stuff, that I almost don't want to do these things because it just leaves question marks everywhere. Now I do have an MFJ antenna tuner. Shame on me for even calling it that. It has 2 meters, a forward and a reverse meter on it. If you're a ham radio guy, you're familiar with what I'm talking about. I rely on that. Am I a fool to rely on it after doing these simple tests? That I have a piece of cable running between the MFJ antenna tuner and my ham radio. It's a short piece, maybe this long. I work the controls. I get the SWR report to be as low as possible. Am I really doing something? Okay, here we go. Same test. 3 watts last time. This time we have 7 watts. I rest my case. You really got to raise a question. Can this ever be reliable? Is there any circumstances? And maybe the answer is really no. Unless you can set up, because there's another aspect. Let's say you were able to set up a situation with a perfectly proper antenna and a perfectly proper feed cable and all the right lengths and everything is absolutely perfect. Well, it's only perfect at one frequency or a small band, range around one frequency. Certainly one band. So if you have, how many of us have this? One antenna. I have one ham radio antenna. And it's not even particularly tuned for anything. It's the amount of wire I had available and the space in my backyard controlled everything. It's not, and it's like an off-center fed. Not because I'm an antenna genius and I figured out how to set up a OCF antenna, off-center fed antenna. It's because that's where the feed point ended up, just based on the geometry of my backyard. So with all that stuff happening, and nothing is in any way ideal, what do you got there? Well, usually you revert to meters like this, or other ways. I have a VNA, a vector network analyzer. Well, I'm going to bring that in here. That'll blow my head off for sure. I have a vector network analyzer. I have two of them, crying out loud. And I've applied them on my antennas. And I have not gotten any clear value out of them. Yes, you can see the VNA being demonstrated on videos. If people have their VNA and then they have a small high frequency antenna right near it somewhere, just a short distance away, a little piece of cable, and away they go, and it seems to work. It seems to work. But put a long feed wire and an antenna in your backyard that's nothing is quite standard or under control, and maybe you get with your VNA what I get with mine, which is this. I get this. I don't know what to make of it. Now I really don't know what to make of it. Oh my gosh. Well, even if I put the load here, and I set up this radio, I make a measurement, I go, okay, that is the measurement that should occur, and then I just take this out of the circuit and stick this guy in the circuit, which is just another one of these basically. But as much as I'm trying to keep it the same, it won't be the same. There's wiring, and who knows what's going on inside here. So yes, yeah, now the watt meter on the back of your house, that's a real watt meter. It's insensitive to imaginary power, and if your voltage is going up and down, that doesn't matter. It's a real, honest to goodness watt meter on the back of your house. This is not. Okay. Yeah, VNA. Let's just blow our heads right off with the VNA here. Okay, so far be it from me to explain this properly. So just take everything I say with a big grain of salt. So we got the Smith chart on here, and you can see this little green spot here, number 1, and I can read what it says up here to you. So right now we have no load on this meter. It's set to RF power, and this is open. What it says is almost 7 ohms and 26 picofarads, and you can see that this is on the capacitive side of the Smith chart here. This is open. This is open circuited, but and also I've constrained the frequency that this is operating at. It's going from 26 megahertz to 28 megahertz. And I have not calibrated this for a while, so I'm guessing it's retained the previous calibration that I did, but it maybe not. So here it is suggesting there's some resistance in here that you can see, and I'm now going to put the 50 ohm resistor on here. Again, sorry you can't read the numbers. There is software I could put on my bigger computer, but that just makes things even more complicated. So now with the 50 ohm load here, I don't know if you saw, maybe my hand was in the way, this jumped a little bit. This now is reporting 34 ohms, still, or 19 picofarads, still on the capacitive side of things. I just hooked up a piece of cable. Now it's reporting 1.7 ohms jumping around, and much more capacitance. You can see it's way down here now. Okay, we'll put the load on. Let's put the load right on me. Okay, there we are. Now it's saying this resistor, well, it's saying this circuit, 2.2 ohms, 134 picofarads. Well, that explains everything. Now it's as clear as can be. Let's just flip this switch around here. Nothing happening whatsoever. That's a little odd, isn't it? I think that actually this is moving ever so slightly down here. Not much. Okay, so I'm gonna go drink some coffee. This just doesn't seem to be any way forward here, where I know for sure what this meter should be reading when it's hooked up to this radio. I couldn't tell you for sure. It could be almost anything. It depends on such tiny factors. Coffee, quickly. Okay, let's get back to working with this one, and see what we can get out of it. Now, go back onto the transceiver here. I'm using the short cable. This is the one that gave me a 4 watt reading I was so happy about. But now I realize that, it doesn't mean much. So it appears. Okay, so we're on the internal load. And we need to switch on the power here. There we go. Hear the relay snap in here. Protective relay. Now, we're hoping for 4. 2.2. Wow, sorry sir, there's something wrong with your CB radio. Your brand new out-of-the-box CB radio appears to only put out 2 watts. Maybe there's instructions, and I hadn't seen them, that say you need to use a very particular length of cable between the transceiver and this box. Maybe. Well, we can increase the power, sir, don't worry. I'm going to put in this power boost cable. A lot of people don't believe it, but these special power boost cables can boost the power of your radio. I'm going to show you. It's going to go from 2 watts. And sir, don't worry, I can sell you one of these cables for sure. They're only $100, but you're going to get all 4 watts finally. I'll prove it to you. Here comes the proof. You better not look at this. Let's see. Here goes the proof. No, it didn't prove a thing. It's less. It's less. Well, maybe this cable's defective, sir. I have to put a different long cable in. Let's try. We can't do this one. I have none others. I have no others. I have no other longer cable that I could easily put in here. So you owe me money, buddy. What for? I'm going to put the anti-cable in. That's right, sir. You're using cables, and those cables, they consume power. So I'll show you that. We'll hook up the radio here with no cable, and the result will be vast improvement in the power outage. I'll show you on the meter. Ready? Watch this. Okay, so 2.5. So you got 0.2 extra watts out of that. Oh my gosh. So certainly you could use this for comparative testing. You could, using the same length of cable and stuff like that. Get these off. You could swap radios, and then you could say, well, this radio's double the strength of that other radio. I think you could get away with that. But the other thing too is the receptive difference between, say, transmitting 2 watts and transmitting 4 watts is not that great. It wouldn't be that significantly different. Oddly enough, you think, well, you double the power, double everything, don't you? Well, not really. Okay, so I'm really stuck. How do you calibrate something like this to know for sure it's reporting the correct output? See, in every case here, this was around 2. But surely to goodness, the actual power coming out of here has got to be 4 watts. When I say that, I don't even know that that's really the case. You could be developing 4 watts, but what's coming out of it? Whoops. You got 4 coming out, you got 2 coming back, they're interfered with. I don't know. This has not been a helpful experience for me at all. It's just left me in the same ball of confusion I've been in for decades on this topic. What it's really done is just proven to me how cornball these tests really are. Or maybe I'm the cornball. Okay, I gotta stop. Coffee helps. So I think a lot of the confusion around this whole thing comes from me forgetting what I was about to say. Coffee didn't help. What was I going to say, for crying out loud? Oh, I know what it was. Antenna tuner. This isn't an antenna tuner. So I have a ham radio, small ham radio, G90 in fact. It has a built-in antenna tuner. That's what they call it. And I bought a MFJ antenna tuner quite some time ago. I'm going to go and look and see what it actually says right on the front face of it. I'll be right back here just in 2 seconds. Okay, MFJ being the smart company that it is, it doesn't call their antenna tuner an antenna tuner. It's called a Versa tuner. Oh, it tunes the Versa. Well, Versa, universal tuner, is that what that is? Versa tuner? So those tuners that we use on our ham radios, they don't tune the antenna at all. They're not compensating for weaknesses in the antenna, especially out at the antenna, maybe where your cable feeder reaches the antenna. Nothing to do with that. It's sitting at your radio. What it's really doing, in my view now, this is my view, and there are many views, you can look on YouTube, is all it's doing is protecting the radio, giving it the sensation that it's feeding a 50 ohm resistive circuit. It's doing this by compensating for the impedance and inductive, capacitive, whatever it is, in your antenna and transmission line. It's balancing them or compensating for them or knocking them out, however you want to look at it, so the radio sees 50 ohms resistive. And the reason for doing this? Protect the radio. It's not about, this isn't a radio, but protect the radio. It's not about getting all the power out to the antenna, because some of the power could be consumed in the antenna tuner if it's not set up just right. And setting those guys up, do you use one? It's got the 3 knobs on the front. Is there a procedure you follow? I don't really follow a procedure. I try the inductor usually first and then fiddle with the 2 capacitive controls. There's 3 controls until things look good. What's really going on though is kind of hidden in this mysterious world. Now it has a standing wave ratio meter. It has a forward and a reverse meter on it, and there's a way to to examine the amount of power that's coming, like this. This also has, this has a reverse meter. Okay, this has a reverse meter, and I did not flip it on. So you can actually see how much power is moving in reverse. You know, the energy that you are exchanging between the radio circuits and the antenna. If you sit and think about that, just think about energy, a term we all use every day, all around, all kinds of ways. But if you really think about it at a physics level, or here in electronics, we often crash into the world of physics. Really think about it hard. All you're left with are question marks about what energy is. So at least that's all I've got. Okay, so we're going to do this again. Here we go. We got a moderately long cable. We get 2.4 reverse power. Very little. So is this telling me something now? Can I trust this? Can I say, okay, the total power coming out of here is 0.1 plus 2.4. So 2.5 is the total amount of power coming out of here. Can I make that statement? Is this correct? And that other meter I got to say 4 watts is not correct? Is the output from this not 4 watts? I don't really know. I still don't know. I don't know. My God. What kind of world are we making for ourselves here? Jeepers. Okay, I got to do something. I got to make a decision. I got to move on with this thing. I got to move forward, so I got to leave. So this is the calibration procedure for the CB Service Master. I'm just reading it over again to see if I missed something. Equipment required, RF watt meter. Now, are they talking about the toy watt meters that I have here? Or are they talking about a real McCoy watt meter? You come down here, it's RF watt meter calibration. Connect the RF output of a properly operating transceiver to the transceiver input jack. So the first thing they're telling you is you need a radio. You know the output is proper. How do you know that? New out of the box. That's what I'm relying on. Brand new out of the box. Here's one. Connect an accurate, calibrated RF watt meter. So in this case, I think it's pretty clear they're talking about a real watt meter here. I don't have a real watt meter. If the watt meter is a through line type, terminate the watt meter into a 50 ohm resistive load. So my problem is I'm not using real watt meters. I'm using voltmeters calibrated in watts, and they're only accurate under very special circumstances, which I can't seem to generate here. So from here on in, it's just what you would expect. Adjust the trim pot until the 2 watt meters agree. Doesn't say anything about the length of cable involved, just says connect. I guess if you're using a true watt meter, this cable stuff, it won't really matter. It's going to tell you the actual amount of power being transferred. So I think that's really my problem here. I'm using crummy meters pretending to be watt meters, and they're subject to voltage variations that are all over the place in this line of work. I think that's probably the best I can do. So how can I adjust this? What can I do? What can I do? Hook up my 4 watt radio and make that meter say 4 watts. It's interesting. It doesn't say that, does it? It says a properly operating transceiver. It doesn't say with a 4 watt output. It doesn't mention 4 watts anywhere. Of course, you know, you could be using other kinds of radios on this machine. It is capable of working with other bands, not just CB radios, so they don't want to name the frequency or anything like that here, I guess. Well, there, let the truth be known. I don't have a watt meter. I can't do this properly. The impression I get is it's reading low. That's what it seems to be. I'd be happier if it said 4 instead of 2, but I don't really know the output of that radio. I'm unable to determine it. Even hooking up to the oscilloscope and making a voltage measurement, you have a cable there and it's causing difficulties. This is probably why you can revert to something like a current flow, you know, in the collector circuit of the output transistor or something of that sort. Oh no, here's another watt meter. What do they say over here? Audio watt. Turn the receiver function switch to that, rotate the load to that, adjust it for 0 watts on the audio output meter. Connect the audio generator input and the audio output receiver jacks. Connect an accurate calibrated AC voltmeter. Okay, most of us have one of these. Across the receiver audio jacks, and then you go through the process. So this is doable. I mean, do you really care about the watt output? I mean, you really just turn the radio up. Is it loud enough? 2-tone amplifier. Well, we heard the tones. Does this have to be exactly 1,000? You know, I'm convincing myself to do nothing to this machine. That's what this has led to. 26 megahertz oscillator adjustment. So this is how they're converting the 27 megahertz radio signal down to 1 megahertz, so you can see it on your scope. That won't go all the way up to such a high frequency like 27 megahertz. So what if this is a little out? What if it's 26 and a half? Well, that may not be so good. What if it's 25? Adjust it to give you 20. And why? Because you're going to make frequency measurements from this? No, you're not. Frequency measurements are coming out onto a frequency counter, and that's working just fine. And there's nothing down here, just the diagram. This has not been a very good journey for me at all. This is really not, it's really more a question of learning the reality of using something like this as opposed to doing, like, calibrating it. That's really what I gained from this. Just doubt everything when you're using these simple devices. Look at this. To do this 2-tone thing, you've got to temporarily connect in a capacitor. Yeah. I'm not going to do any of that. I think I'm done with it. I think the most I would do is I'd make that meter go higher, based on the radio here. I would just hit the radio and adjust this so it says 4 watts or something a little higher than 2. Let me say a little more here, just thinking about it. So this is the calibration of the watt meter I've been fooling with. Look at the last statement. Adjust trim plot R12 until the 1040 RF output meter and the external watt meter agree. And now I know from fooling around here, once you have these 2 meters agreeing, if you change the length of a cable anywhere in this system, I guess you might be using only 1 cable from the radio into the machine here, you're going to get a different result. So basically what it should say here is pick a cable you want to use all the time, like a certain length. That be the cable you use for every radio, and then go ahead and make these adjustments, but always use that length of cable afterwards. And is that even a guarantee? I'm not even sure of that. I don't know. I have other brand new CB radios. It's a little tough for me to bring them in here. Yeah, I don't know what I'm doing here. Okay, here's what I'm going to do. Really, it's actually really not the right thing to do, but I'm going to do it. So I have a radio connected with basically no cable into here. The adjustment is right down in this area. You can see where I'm poking right in here. And I'm going to adjust that meter to show 4 watts with this guy transmitting. Or is it already showing more? Let's get it around here. Now I got the meter on its side, which isn't very good. The radio just hanging off this connection here. Hanging in space. Seems to be okay. Okay, let's hit the button. And it shows the same 2.5 or so. Now I'm going to make that say 4. That's my plan. I'll put the screwdriver in here. What's that. What kind of a screw goes in there? Just a flathead. Why couldn't I get that? My screwdriver is too big. Wait a minute, that's not right at all. Okay, let's try this one. Okay, I'm in. Here we go. 4. Can easily get there. That ended up at 3.5. There it is. I have completed the calibration process, my own version of it. Yeah, it's all baloney, isn't it? It is baloney. But it's not baloney if you do a comparative thing. So if you were in a shop and you had a brand new radio, which you would back in the day, you could pull it out, just like this one, stick it on there and see what it says, and then go, that's the output of a good one. Or you can put up your item under test and see how it compares. And if it comes back reading higher, you just tell your customer he's got a heck of a good radio. I don't know. Or if you were in a serious shop, you'd have probably a real watt meter. That's probably what the situation really would be. The rest of the calibration I'm going to give up on. None of it is really going to be helpful. Probably the unit is fairly well calibrated anyway. And I don't think there's too much to gain. As for sorting out the problem with the percent distortion, I'm going to ignore that too. So it is what it is. So we can do lots of stuff with this. There's no precision readings with this guy. And okay, that's been a kind of a miserable journey because it didn't go at all the way I expected it would. And I think I'm done with that gizmo. Wow. So the last thing I'll say about this stuff, cleaned up kind of nice, looks okay. Signal generator appears to work just fine, and you can get stuff out of this, and if you don't get all tied up in knots over the accuracy of the watt meter, it can still be used for comparative purposes and that. Thinking back in the day when this would be in a commercial repair shop, and somebody would come in, an innocent CB owner would come in and he would make a statement, and this probably happened a lot. I don't think my radio produces the power it should because, you know, Bill seems to get a lot better distance than me. And of course, a good operator would realize, well, radio, cable, antenna, everything all together is what's really controlling the final output of the antenna. But nevertheless, there he would be in your shop holding his radio. I don't think this radio is working. And so you would want to turn to something like this and find out what the real power is coming out of here. But I think, you know, what I've learned is you need a real watt meter to do that. This is not a real watt meter. This is a fake. And it's really not much better than, you know, this other one I had. This guy. I'm sure they're just voltmeters calibrated. So you'd be in a difficult situation where you could hook up his radio to this meter using a certain length of cable and get a certain kind of reading and then make statements to your customer. Oh, look, it's not putting out the power it should. Or, oh my gosh, it's putting out 6 watts. Yeah. What a problem. Yeah, so for those of us who are doing ham radio stuff and that, We need real watt meters to do anything real. I think that's what it boils down to. I think the meter in the MFJ is also just voltmeters. I don't know that for sure though. I don't know. I'd have to look. Maybe I'm denouncing MFJ and I shouldn't. So that's it for this stuff. Hey, if you want this stuff from me, I don't think I really want to keep it. You get in contact with me and we can talk about how you could acquire signal generator, frequency counter, control panel, and this big old scope. It could all be yours. Thanks a lot for watching, and I'm going to get back to working on something I'm more familiar with, like maybe a radio. Yeah, that's a good idea.